Okay, thank you for all coming here. What possibly go wrong? There should be a title over there, but my system with Linux and Beamers didn't work quite well. So I think we have the topic for today. So the title should be OpenShift for the Enterprise. So I hope the rest will work. At least that works. So my name is Tobias Denzler. Originally, I'm a Java developer, but over the last years, I've shifted more and more into the Kubernetes OpenShift world. I worked in several larger OpenShift projects over the last years, formerly at SBB. And some months ago, I joined Helvetia Insurance. And there we're currently building up a production OpenShift cluster on AWS, trying to run the insurance workloads we have. Today I would like to speak about 10 key points or 10 key topics you probably already know, and if not, you have to know it when you go to production with enterprise OpenShift setup. It's a small mix about best practices and lessons learned from my point of view and we learned in the different OpenShift projects. That font size is working. Great. Okay. Topic number one is infrastructure sizing. What I mean with that is size matters, and it depends how big your cluster is, how your cluster is sized, how big your nodes are, and stuff like this. So sizing is important, especially if you have many containers in production or in a cluster. So why it is better to use 10 small nodes instead of 5 big nodes? When I talk about sizing here, it's all about CPU and memory. It's the most problems you have with big nodes is evacuation. So evacuation means if you have to migrate the node or you have hardware failures. So every single container on your node is evacuated to a different one in your cluster. So if you have small nodes with, for example, 30 or 40 containers on it, you can evacuate really quick. If you have nodes with 120 containers, that's the current Kubernetes limit for one node, that will be quite a pain because suddenly the scheduler has to reschedule over 100 containers to a new place. And that's quite a load on your production cluster. It's also what you can run into is you can run into I/O issues if you have too many containers. Of course, it depends, but if you have 100 containers with heavy logging stuff and high I/O pressure, you can have issues there. You can also, at least what we observed in the past, is you can have issues with IP tables. So this whole container world is built on IP table rules. And if you have a lot of changes in your cluster, you can get locks on your IP tables. That's one thing that could go wrong. At least what you need to do is you need to have an idea how many resources you have to sell or to bring into your cluster in the future. So for example, we currently use Prometheus and Grafana to have a forecast about memory and CPU so we can estimate what to use or what to provision for the future. It's also a good practice to separate application load from infrastructure load. Means all the infrastructure containers you use, for example, registries, monitoring, Prometheus containers, application or logging stacks, put them in a separate cluster and use it there, or at least run it on dedicated infrastructure nodes inside your cluster. That has two advantages. First, you can separate the load better for infrastructure and application. And the second one, you do not have to pay for infrastructure nodes, at least if you go enterprise. And the last point, control is power. I think that's clear. The more you control on the hardware side, the faster and the quicker you can react if something goes wrong or you have to provision new nodes. Automate. If you have ever worked with OpenShift or Kubernetes too, I'm sure you know Ansible. There are a lot of Ansible scripts to build up OpenShift clusters, also for the enterprise, not only for the origin version. So use them. They are really sophisticated, but do not forget you have to script the infrastructure too. So if you use, for example, AWS or any other cloud provider, there are some reference architecture that automates the provisioning of these resources. But as soon as you add additional resources to them, for example, add specialized DNS nodes, add external storage system, add VPN tunnels, script them too. It's not so a big issue because there are really cool modules for Ansible that you can use, for example, for AWS. I know the other things that might be quite obvious. Try to automate other things. And then there's the question where to start. So keep an eye on what the team in his daily business do and try to automate the trivial things that you have to do each day on and on again. So these minor or these quick fixes are really nice to automate. But also, if you do great new stuff, do not forget the legacy tasks. So you haven't won anything if you can set up your cluster in 5 minutes, but you need to wait for the firewall for 5 days. So that has to be in balance. And the last point, what's also important is the developer experience. So try to make it fast and easy for the devs to go to production. So try to automate, that's what I call one click to production pipeline, where the devs can commit and the pipeline runs through to production. So that's also kind of automation. Failure. So for production, a single pod is never enough. Most of you know that. It's also the same with containers. Kubernetes and OpenShift in a cluster, you cannot count that your pod is always running. There can always be an issue, might be a hardware failure, but also no maintenance. So the ops team take out the node completely, and your container is moved to another area. So at least 2 pods for production. And what I encountered often a problem is, and there is sometimes a huge gap or a mind change from the classic two-way server load balanced application setup to something like Kubernetes or OpenShift. So you really have to establish the understanding of failure. So your teams need to know their application can fail at any time, and they need to design it for that. So what you also can do, you can train them by using, for example, chaos monkeys and provoke these failures. So at best, provoke it on dev, provoke it on test, do it on int. At least they might be ready for the failure in production, so they are trained for it. And also use libraries that can handle failures. There are a lot of them. Use best practices, design patterns, and also use the core concepts of Kubernetes and OpenShift. We already heard the health checks, use them. That will also help you to come over the failures. DevOps, there are some points, especially for enterprise, when it comes to DevOps. For startups and the big tech companies, it's not so a big challenge as maybe for, I say, the older or the more traditional companies. If you go for DevOps, of course you have more power as a developer, but that also means you have more responsibility to take. So suddenly you have to care about how I build my build chain, what's with monitoring, do I have to do 24/7? What happens when in the middle of the night my application crashes? It's my responsibility. So that's a huge shift also for the developers. And what's also kind of challenging is a container platform also means there is now a huge field of new technologies you can use instantly. But that also means you as company have to build up this knowledge about these new technologies. So maybe for a start, it's good to do kind of restriction what to use, that you can handle this knowledge better. In the end, it's also a question, is DevOps really suitable for my organization? That's more the classic way. So one DevOps team from dev to prod, and also responsible for ops and monitoring. But in my opinion, this approach doesn't scale. So for example, if you are a company that's having 200 applications, means 200 teams doing 200 times 24/7. So as an enterprise company, you cannot really do that, at least from a point of cost effectiveness. So maybe go for SRE, combine applications, combine technologies, give them to specialized SRE teams. That would be a good point. And of course, also try to mix your teams. So be sure you have the firewall guy in your team and not on the upper level of your building. Be sure you have a guy with deeper storage knowledge in your team. That will help you too. And last but not least, humans are your biggest legacy. So the technical parts are often easy. That's stuff we can do. But changing a culture, that's a big thing. And you have to work constantly on that to bring your people to the next level there. Container clustering means the classic clustering for an application. That's most often quite straightforward. But what's happened with clustering with other technologies? What's happened with database clustering or messaging clustering? And there you have to ask yourself the question, is Kubernetes or is OpenShift the appropriate way or the appropriate environment for such a technology? Or maybe is it better to run the database externally, run it on AWS? Because as you all know, in environments like Kubernetes or OpenShift, you cannot rely on the IP you have. And that's often a problem, or at least a challenge. So if you want to form a cluster, you often need to have an IP, or at least several IPs. So what you typically would do, you would use or write plugins that go to the Kubernetes API, grab the endpoints or service, and asks for the IPs of the pods behind that service. And based on this information, you can form your cluster. Another point you have to look at is if you have all inside your cluster, means your application uses a database in OpenShift itself. That's not a big issue. But what's happened if you want to, for administration or for maintenance reason, want to access your database cluster from outside your OpenShift cluster? That typically do not work, as OpenShift as a cloud platform only supports HTTP and HTTPS. Of course, there are some ways to overcome that. You can use external services, specialized node ports, if you're familiar with that. But there's also the question, isn't it easier to run it on AWS and have out-of-the-box access to that? As you may know, there are some open questions, and I will not answer all these questions. So some of them you have to decide for yourself, or at least for your company. Golden image, or also base image. The idea behind the golden image is use one image to rule them all, basically. So take what probably each application in your company will need anyway, and try to bring them in one single base image. For example, take a Red Hat Linux, use the Java 8 in a fixed version, add custom company certificates, add your monitoring agents, pack all this stuff together so your applications can use that image and do not have to care about the life cycle of operating system, Java versions, agents, and stuff like this. It's also easy to restrict or to control the life cycle of such images, because you can bear on that each application uses the same base. It's easier to do image scanning, to do life cycle of older components and stuff like this. Application scaling. For platforms in the cloud, scaling is often not a big issue anymore. In OpenShift or also in Kubernetes, it's a point of one click or some 1 or 2 seconds, and your application is scaled. But unfortunately, this is only half the battle, because often you have older legacy backends, older legacy systems you have to call from your OpenShift containers. And the question is, how do they behave under load? There is a small story. Some guys know there already. Once we had a mobile application, and this mobile application was backed by a backend on OpenShift, hosted on AWS, so highly scalable. Marketing announced a new version, completely relaunch of this application, and big press and television reports. So all kind of cool stuff. The system was designed for about, I think, 15,000 requests a minute, and that was completely fine. Then the problem was, as soon as the television report comes out, hundreds and thousands of people were downloaded the app, and there weren't 15,000 requests, but 60,000 requests. So around about 4 times more than the system was designed. So what happens is the pods, they collapsed. The complete system goes down. But then what we have done is we scaled up on OpenShift. So because it only was a matter of some clicks, that was quite easy. So all the complete backend on OpenShift could handle the load easily, but then the traffic was constantly flowing to the backends, and they broke down, and I think there was about 90 million pending requests waiting on some answers from the backends, and so in the end, it doesn't work anyway. So you have to scale your backends too, and not only your cloud services. Databases. We have heard some slides ago that there are some challenges with databases. For databases, it's hard, or it's a challenge to live with this constant failure of such a system, because you cannot count on long-running processes on a cloud platform. So you need some concepts of clustering to prevent downtime. You can do that with master-slave approach, but that also gives you a kind of downtime on the right side. You can do it with master-master approach, but not all technologies really support that yet. There are a lot of additional points you have to cover if you run databases on yourself, on Kubernetes or OpenShift. Backup, restore, point-in-time recovery, monitoring, all this stuff you have to do on your own. So why not run your database outside of OpenShift as a service on AWS? Maybe you can also mix the things. So for dev stages, maybe it's enough to have a single container Postgres database, because if that one goes down, it doesn't really hurt me much. But if you go up the stages, go for external services like AWS, highly available things for production. So there you have to choose. Sorry, that was a bit too fast. Contribute. As you all know, Docker, Kubernetes, OpenShift, or at least OpenShift Origin, all open source, and that's great. There are a lot of tools and scripts around OpenShift and Kubernetes that will help you to build up your stuff, to manage it. So use them and maybe also contribute to them. Try to open source your own stuff. I know traditional companies, it's not always so easy, but try it. Maybe you have a cool discovery, a cluster discovery plugin for your technology. You have self-service tools, or you have some monitoring stuff you can open source. It doesn't have to be a big thing. And also have an eye on the internal contribution. What that means is, if you define standards for your company, design best practices, CI/CD pipelines, demand for internal contribution, because your projects, your application know what will work. So because they tried it, try to contribute internally to best practices and standards. That will help you also. I promised you 10, and means that's the last one. So, security. We heard a lot about security from Rashid, and there are a lot of security concepts built in OpenShift already. So we have network policies for firewalling between containers. There's traffic encryption all around the cluster. All containers run unprivileged per default, so no root access for no container. You also have, at least if you run it on Red Hat Enterprise Linux, you have SE Linux per default, what gives you an additional layer of security. You also have image hashes, the topic we heard before. That's the standard way of pulling an image in OpenShift. If you know Istio, Service Mesh Istio, it's a relatively new thing, brings additional security features, mutual TLS, fine-grained access control. There's a lot of concepts you can get from there. We also do encryption. We encrypt our persistent volumes. Because we are on AWS, that's relatively easy. It's nothing more than a checkbox you have to click. The same with databases. Encrypt your databases. So you are more safe on the data in rest or data in motion. And there are some additional tools in OpenShift that can give you audit logs, so that, for example, you see what's happening on your APIs, who called that, who deleted this resources and that, and you can build your security audits based on these informations. So, that were my 10 topics. So, thank you. I'm around here the whole day, so if you have questions, come to me and we have a little talk.